Imagine you're in a coding interview at a renowned environmental research company. You are given a problem related to animal studies in a forest. Your challenge is to analyze an array of animals, and count how how many of how many have a specific number of legs. So, an array of animals and count how many of them have a specific number of legs. Alright, so your task is to write a program that examines an array of different animals and determines how many of them have exactly four legs. So, exactly four legs. Simulating a real world coding interview scenario. Um, so, simulating a real world coding interview scenario. Alright, given an array, problem statement, given an array, animals representing different animals in a forest. Return the count of animals that have exactly four legs. So given an array, animals representing different animals in a forest, return the count of animals that have exactly four legs. An array animals where each element is a string representing the name of an animal, right? Representing the name of an animal. String representing the name of an animal. Okay. An integer representing the count of animals with four legs in the given array. Representing the count of animals with four legs. Animals with four legs in a given array. Input. Mm. So input animals. Input animals. Lion, monkey, deer, snake, elephant. Output 3 explanation in this array. Lion, deer, and elephant have four legs. Example 2, frog, horse, spider, ant. Output 1, only horse has four legs in this array. The list of animals and their leg counts. Animals with four legs, lion, deer, dog, cat. Animals with two legs, monkey, parrot, ostrich. Animals with no legs, snake, worm. Animals with multiple legs, more than four, spider, ant, centipede. And then the submission requirements, diagram or flowchart so it can help you and the interviewer stay on the same page, clarifying questions, test cases. Yeah, I got some questions to be honest. I mean, I've noticed like the names are all lowercase. I mean, everything here seems lowercase. So, should we assume that the string animals, right? Um, or the input array. Should we assume that the input array is lowercase always? Um, and I think also, what if the string is empty? Should we, I don't know, like make an if condition, an if statement to confirm if um, the string is empty or not, or should we always just assume that the string is not empty? I don't know. A couple things really just to put out there. I assume this is a good question for an interviewer. But anyways, time and space complexity of your solution. Time and space complexity. Yeah, time and space complexity measures. I know that it measures the performance and efficiency of an algorithm. So it's really just to measure the performance and how efficient our algorithm would be. Okay, and then so what else do we have here? Send time, space, maintain clear communication throughout the interview. Reiterate this point as it's crucial and worth repeating. Okay, we'll try our best here. Find your solution to improve its time and space efficiency. Explain the trade-offs and how the optimization improves the original solution. Okay, so what I understand from here is we should map the names of the animals. We should map them, and let me see here. So we map the name of the animals to their legs, to the number of their legs. So number of legs, name, so that's string and what, integer. So yeah, so string and integer. So key value pairs in a map. All right, let me start with the flowchart real quick here. Let me say what's the terminal that over here. Let me see to downloads. And let me touch. Let me touch flowchart. Empty. Let me open that flowchart. Okay, so let me start here. And well, let me have all right, so let me create a map. Right, so I'm gonna create a map just like I said. So we're gonna create a map so that we can have our have the names of the animals as the keys and their respective number of legs as values. All right, something like the names as keys, and the integer or number in this case, right? Number of legs. Let me just say integer. Sorry about that. And I'll say, so we're gonna create a map, right, of so we're gonna create a number. All right, let me say a number of legged animals, right? And I saw somewhere here about count. Let me see here. Yeah, your challenge is to analyze an array of animals and count how many of them have a specific number of legs. All right, yeah, so we initialize. We initialize count with 0 or 0. And we're gonna loop through here. So let me say for each animal in the inputs, right? The input, let me say, for each animal in the inputs. I'll say if the animal is in the map, right? Then we increment. Let's increment here the count, right? We increment the count. Output format, an integer representing the count, an integer. Oh, okay, so we should have an integer representing the count of animals with 4 legs in the given array. So representing the count, an integer representing the count. So we return count. And yeah, that's it, output, right? And I end here. Let me go ahead and save that. Yeah, so we create a map of n-length animals. We initialize a count at 0. And for each animal in the input, if animals in the map, we increment count and we return the count. Okay. Okay, looking good. Let me store this over here. Let me store this over here. Alright, so with that, let me open a editor with JR. Does it say the name of the project? Probably a good question to ask as well to an interviewer. What is the name of this project here? Let me see, animal leg counter. Animal leg counter. Let's use this flowchart here. You know what? Hold on. Let me confirm here something real quick here. Okay, let me move this flowchart here to the animal leg counter folder. Let's see. To the animal counter. Alright, we're gonna cd to the Alright, and here we have our flowchart right over here. Let's go ahead and open it. Okay. Save this over here. Alright. This over here. Save it up like that. Okay. Save public class animal and counter. And I'll say public static static let's say public static, what am I gonna call this? Say count 4, right? We're counting 4 elect animals. Oh, we're gonna return as well integer, so public static integer, and so we're gonna have a string parameter, an animal string parameter, right? Animal string parameter. Animals. Yeah, animals. Shall we? Let me check my flow chart here. Create a map. Okay, so let's create this map. Let's create this map. We're gonna have the name, so string, and the integer. What am I gonna call this? Animal legs, I guess. Animal legs. And I'll say new hash map. I'm gonna do this in a hash map. Hash map, diamond operator, there we go. Yeah, I'm assuming I should already import here the hash map and import the map. All right. So we have that. So let's go ahead and create our, let me do animal legs. Animal legs. Save that put. Right. Here's put. Go ahead and see what do we have here. Animal legs put. Is put even correct? See here. Okay, we have lion. Let me check something. Lion 4, right? Copy that. How many do we have? 2, 3, 4, 5, 6, 3. Let me do it like this. 3. Let me copy every 3 times like this. Alright, so we have lion, we have deer. Oh, deer. We have elephant. We have horse, dog, and cat. And then we have, what do we have? 2? Oh, I thought it was 3. But anyways, 2. We have monkey. Is that parrot? Okay, parrot. And we have ostrich. Ostrich. Put some space here. And we have ostrich. Then we have what is that? 2? No legs. No legs, so that should be what? 0? 0. And we're gonna use snake. Worm. Worm. Worm, snake. Trying to see. Okay. Do we have multiple? More than 4? More than 4. Okay. Let's say spider. How many legs does a spider have? I'm not sure how many legs a spider has. Centipede. I'm just gonna write 8 here, I'm not sure. Ant. 12. Maybe less. 6 maybe? Let me say 6 for ants. Centipede. Centi is easy. Centi 100. Okay. Let me check my flowchart here. Flowchart. Where is the flowchart? Okay, we got here. We created the map. Now let's initialize a count with 0. Alright, let's see, count. I'm gonna say it's 0, right? And let me have this right over here to help me out. So we say 4, right? So for each animal in the input array, if animal is in the map, increment count. All right, so we can say if I is less than animals, say the animal's length, right? Animal's length, and I'll say I plus plus. Hold on, let me fix this real quick, yeah. I'm gonna say the string animal, assign it to the animals index, and I'll say what if animal is in the map, right? We gotta check if the animal is in the map. So I'll say say so check if animal is in the map. If animal is in the map. All right, so we're gonna check the animal flags. We're gonna say get or default. Say animal. So we want to see if the element, right? If the element, which is the animal here, if the element is in the map. So we know that this is an element, this is an element, this is an element, this is, and so on, so on, so on, so on, right? So what we want to know is the number of its legs. So we know that the number of each leg in an element is well, we know it's a second, right? The second index. So, but then, assuming we know it's a second index, so we can either do a -1 or 1. -1 to represent the last index, right? Which is the number of the legs. So we can do this. And we want to check if this is equal to 4. If the number, if the number of the index is equal to 4. And if so, we can then increment counts. Right? The increment counts. We can then increment counts. Right, and then we missing return statement. Yeah, I got it. We're out of the loop here. Let me add this over here. Let me return it over here. Return count. And there we go. Compile this. Pretty simple. Pretty simple. So let me see. Yeah. If possible, refine your solution to improve its timings. But yeah, to be honest, I do still feel something about. I don't know. I feel some type of way about the map. Like, hold on. I got some questions, but since we have to imagine we're in a coding interview, right? So I got some questions. Like actually a lot of questions. But probably the main one would be like I feel like this is just waste. Like this is like waste of storage and time. And we have to be efficient in this algorithm. So I don't know, like I feel like we don't really have to worry about all these other arrays here, but this one over here, like the list, this is like technically the only list we have to worry about, no? Because if you really think, if you look at it, there's a part here where it says something about exactly. It's always mentioning exactly. Yeah, like exactly 4 lakhs. here as well, exactly 4 legs. Like determines how many of them have exactly 4 legs. And the reason for my question is that I feel like if we create really just one, like a like how do I say, of all these lists, right? Of all these sets of lists, if we just create one set here, which just like if we have a constant lion, deer, elephant, horse, dog, cat, then any other name, no matter if it's no legs, 2 legs, or multiple legs, right, in the input that is not part of these 4 legs, it will just output a 0, right? So if we then just, what I'm trying to say is that if we create a constant for this 4 legs list, right, and the input is anything but this, it will just give 0. I don't know. Could we prove this theory correct? This could be a. It's kind of like a question, a long question, but my question is probably: do we have to? Is it necessary to? I don't know if that's a valid question, but should we only just focus on the animals with 4 legs, right, for more efficiency and better performance? All in um, the time complexity of our code is O of n, right? The space, I'm trying to figure out the space here, however, should be O of 1, I think. Let me check here again. See here. For each animal in the count. Yeah, so the time is O of n, where n is the number of animals in the input. Hold on, let's wait. Let's try to let's redo this. Inside this class, let me create something like this. Let me get a private static. I'll say final. I'll say final, and I'll say a set. All right. And this set, I'll have only string, and I'll say 4. All right. I'm not gonna say any more animal legs. I'll just say 4-legged, 4-legged. Hold on, let me correct this part here. 4-legged animals, right? And new hash set. I'm gonna say this into set. In this, we're gonna say I'm gonna say array, right? List, and I'll save just the 4, right? The 4-legged animals here, which is lion. So lion, and I can probably just go ahead and save myself some time here by doing this. Okay, it's in. All right, let me just do it like this, anyways. So lion, deer, deer, right? Deer, elephant, horse, and cat. Dog and cat. Right. Oh, we're gonna have to import this instead. Let's import the set. Let's import the hash sets. Arrays. Let's import as well arrays. Java.util.arrays. Okay. And I don't think we're gonna need this map here anymore. Alright, we can just go ahead and remove this for now. I feel like even just with this small improvement already improves our code. Let me go over this a little bit here. Well, let me just assume the interviewer probably asked me the questions like why static final, right? I mean, final, you should know it's constant, of course. And why did I declare here this set as static? So this is static so that let me correct this here. This is static so that okay, let me try to come up with my words here. It's static so that the code, right, so that this list becomes reusable, or the set becomes reusable, the four-legged animals, right, becomes reusable within the class itself. What do I mean by that? If I don't declare static, every object, right, will create a copy of its own. So when I create an object, right, it will have so if I create an object, it will have how do I say this? It'll create a copy of its own, and that's just waste of memory, to be honest. Yeah, so the static just allows, and it's also helpful because if I don't do this and I try to test this, for example, let me use a comment section here. Oh, let me actually do it like this. If I don't use this and I try to test this, I hope this really, but don't take too long here. And I try to test this, right? I'm gonna have to instantiate a whole new object, and I hope that makes sense. So without static, for example, I'll do like an animal lag counter, right? And I'll say count for where is this? Lagged. I just noticed there's a typo here on my part. Big typo here. It's fine. Yeah. So count for lagged animals. Right. Animals, right? Or let me do something like this. So animal lag count, lagged animals, and let me see here. I'm gonna have to hold on. Right here, static. sorry, this is actually with static. Let me do it like this. If it's static, right? Static. And let me say without static. So you're without static. Without static, you're gonna have to do like an animal lag counter, right? And then counter, which is just a name for the new animal lag counter. And then you're gonna have to include, let me do a counter counter dot count, right? For, yeah, that's correct. Yeah, so for lagged animals. And so without the static, essentially you're gonna have to do this for every object and or method or whatever that you try to call, right? But with the static, right, this is just all you need, right? This is it. So the code is just more reusable and more useful. Hope I didn't take too much time, but yeah. So let me just do it like this here. Static. Let me do a reusable code. Reusable, clean, and probably even efficient code. Anyways, moving forward, where were we? Let me check my flow here. So create the set. Now this just becomes a set. This change to set, and we'll leave it at the string, right? Leave it a string. Okay, so we are gonna say let me say your conductance. Clear this out here. Got this cleared. Got that cleared. I can use an enhanced for loop here as well. I'll just say for string animal, right? Animals, right? And we don't need this here. Oh, we don't need that. Let me just redo this as well. Redo this here. And we can say if the for, right? If the for, yeah, the for liked animals, because then we want to check. See, animals in the set. Yeah, animals in the set. So we want to say if the four-legged animal animals, right, contains say animal. Oh, something here that's wrong here. Okay, there we go. Let me correct it like that. Alright, so animals, right? Animals. And yeah, if the four-legged animals contains animal, so if it contains the element, I can then just do a count plus. Let me fix that part here. All right, let's see. See, I feel like this is just so much better. Even when it comes to readability. Let me remove these two lines here. Look how much we actually just reduced the lines of our program, of our code. Not that it probably matters so much, but yeah, the flowchart here should probably have another empty, but let me just save here. So the time complexity, let me do something like this. So the time complexity, let me say time complexity is O. Is that even correct? Yeah, O. Wait, it's big O, right? So O of n, right? And space complexity. Well, some of you might be asking, how do I know it's O of n, right? It's, like I said previously, it's O of n because n is the number of animals, right, in the input array. Well, what is O of n exactly? It's linear, meaning, you know, the steps grow directly with the input size. So what do I mean by the steps grow directly with the input size? Let's just say, let me see over a simple analogy. The steps grow with the input size. Let's say dogs, right? Let's say you have 5 dogs, right? For 5 dogs, you gotta do 5 steps. For 10 dogs, you gotta do 10 steps. So it grows with the input size. So O of n, right? And the complexity is O of 1. Since since I stored, like, I stored a small fixed, right, fixed amount, fixed size of 4-legged, right? Let me say it's O, something like this, O of 1, right? And yeah, so constant time, that is, you know, no matter how big the input gets, the steps stay the same. What do I mean by that is that we have here a fixed 6 names here. So lion, deer, elephant, horse. 6, right? Yeah, so we have a fixed 6 names here. And so no matter how big, right, the input gets, right? So no matter how big the input gets, the steps are the same. So O of 1. O of 1. The loop is also O of, oh, the loop is O of 1. Yeah. Somewhere along those lines. But yeah, this is the time complexity, I believe, is O of n, and the space complexity is O of 1. See here. Let me see. Let's go ahead and test this, right? We want to make sure it's start testing to make sure we're getting what we need here. Let me do a quick test here just to check some things here. Let me open up here. create a unit test here, test class here, go. I don't really need this. Okay, we can just go ahead and clean up. Okay, I'm gonna say public class animal leg counter, so it's gonna be animal leg counter test. And let me say test here. I'm gonna say public void. And I'm say just want to do a quick test here. Let me just say test one. And I'll say string animals. Hold on, see something here. I'll say string animal, and let me say, all right, let me get a line here. Let me get a monkey. Let me get a monkey. Let me get our deer. Let me get our snake. Right, for input number one, right? Snake. And let me get an elephant. Okay. And I want to assert. We're gonna assert what? 3, right? We're doing the first example here, 3. So we want to assert. Oh, did I write a plus sign here? I meant an assignment operator there. So we want to assert equal 3, and we want to say that the animal leg counter. Let's say the count for lagged, right? Lagged animals. And this goes back to what I was just explaining about the static, right? Let me quickly compile this here. This goes back to our explanation here, the reusable, clean, and efficient code, right? So animal lag counter count for lagged animals, right? Helps with static. Without static, I'd have to instantiate a whole new object, animal lag counter, and really I could probably just do this in a before annotation, in a before each annotation in the unit test, but I don't know. But yeah, it's just more code, right? It's just more code. So we want to make it efficient. So let me just quickly run this test here to confirm and that we test it all. Perfect. So that means this is passing. And let me test example number 2 as well. What is this? Let me write example here just to follow the same line here. Example number 1. And let me just do a copy of all this here. I'll do example number 2 here. example number 2. The input are frog, right? Let me see, frog and horse. Horse, spider, spider, and ant. Yeah, an ant. And we want to assert 1, right? See, so we're gonna assert, and let's compile that. Let's run example number 2. I don't see where that is. Let me just test all. And here we have it. So we have example number 1 and example number 2. So we have it passing, right? And so yeah, so I guess I was correct, right? We didn't necessarily have to focus on or try to map every other animal if we really just need to exactly determine the 4 legs, right? We just have to focus on 4 legs here specifically.